Yes, you're welcome. This is Solomon at Solo for Math. This is another episode about differentiation, and today I want to look at some examples. Number one, we are going to differentiate the following. Differentiate A. If you have x squared into 5x minus 3. Let's start with this one. We need to maybe let this function be equal to y so that it becomes easy to relate with when we are differentiating. Okay, so if you let the function to be equal to y, we need to express this function in terms of x to power something. Remember, so far we know the derivative of a function of x, which is of the form x to power n. This is what we've looked at so far, and we say that that derivative is equal to n. The n drops, the power of x drops, and then we reduce the power by 1. So meaning we need to expand this so that it appears we have terms in this form. So our y will be equal to x, that will be 5x to power 3 if you expand, minus 3x squared. Now when we go on to differentiate, you can see that we are going to differentiate this and this. It is a bit easier because now this is in this form and this is also in this form, leaving out these the coefficients. So meaning to differentiate this gives us the dy dx, which is equal to, we said this is a 5, the 3 drops down, so times 3 x to power 3 minus 1 minus 3 times the 2 drops times x to power 2 minus 1, which gives us 15 x squared minus 6x, and that is the derivative of that function. Alright, so as we go on, you realize that these are some of the easiest derivatives. You may not need to go through all these steps. You can just go direct from this step up to here. But for now, we're using this because these are some of the introductory lessons. So if you have this, we are differentiating this x plus 4 into x minus 4. We can still let it be y, so that we relate the derivative to dy dx. But if you don't have the y, then there's no way you can say that the derivative is dy dx. So when you differentiate, or we need to do the same, expand this so that you have terms that look like this. So this one, I can clearly see that this is a difference of 2 squares, giving me x squared minus 4 squared, which is 16. So meaning I have y as that. So when we get the dy dx, this gives us, we say the 2 drops, reduce the power by 1 here, and then we say the derivative of a constant is 0. So we have minus 0 plus 0, all the same. So this is giving you 2x. Yeah, so if we consider another example, if we have c, we are differentiating 6x to power 4 plus x squared over x. What do? We can still let it be equal to y for the same purpose explained before, just to make it easy when differentiating, or to relate the derivative to dy dx. We need to introduce the y. So we express this function in terms of the terms of x to power something, the powers of x. So this will be equal to, we can, you see x is dividing everything, so we can divide by x, even this one by x. So this one will give us 6x to power 3. Okay, then if we use indices, this one will remain x, so we have y as that. So dy dx will be equal to, we say the power goes down, so times 3 times x to power 3 minus 1 plus, we say this one is x to power 1, so the 1 drops, and then when we reduce by 1, becomes x power 0, which is giving us a 1. Or we said when you have a function like this, which is linear, when the power is 1, then we just take the coefficient of x, which is 1. So this one gives us, this is 18x squared plus a 1. We are good to go. And maybe D, we can look at this simple one. If you have something like that, differentiate 1 over x squared. If we begin by letting it be equal to x squared, if we express this as an index or remove that fraction, you know when it comes up, this comes up, it becomes like the inverse of x squared. So if we're gonna differentiate, this will be dy dx equal to the negative 2 comes down, this becomes x to power negative 2 minus 1, giving us negative 2 over x. This is it was negative 3, this is negative 3, so when it comes down it becomes this. Alright, so that is it, as simple as that. If we look at another example here, write down the gradient function of the following. We want to get the gradient function. If you remember in the previous lesson, we said the gradient function is the derivative of a given curve. Actually, these are curves, following curves. So like when you differentiate the curve or the equation of a curve, what you get is what we call the gradient function. So for example, if the curve is y equals to 3x to power 7, then the derivative, the gradient function is dy dx, meaning we differentiate this will be 3 times 7 x to power 7 minus 1, giving you 21 x to power 6, and that is the gradient function for that curve. Then where you have maybe b as y equals to 5x squared minus 3x, any curve that you're given, what you have to do is to differentiate. So when you differentiate this one gives us 10, because the 2 comes and multiplies the 5. So this one, reduce it by 1, it remains 1. And we said when we have a linear function like this, then we just take its coefficient, which is negative 3. So this one gives us 10x minus 3. That is it. Thank you for watching. If you have any question that you want us to handle, send it via the comment section. We shall be glad to handle it. Wait for the next episode about the further derivatives and the methods of differentiation. Don't forget to subscribe. Thanks for watching.